Hello everyone, we are Group 17 and our final project topic is about real-time translation in academic communication. Because some international students have many troubles in academic listening and communication due to language barriers, it is necessary to develop efficient and universal real-time translation method to achieve academic barrier-free communication. Here are several novelties in this project. We will connect the local device to the Google Cloud so that there is no need to download the installation packages. Real-time captioning allow a user to focus more on the lecture than on the software interface. The real-time recording function will save the speeches locally after the translation is beginning, so that user can check the missing point and the content at any time. We will have added an automatic summarize feature to it so that the user can quickly understand the main idea of this presentation.
Okay, let's talk about the data set. So since our system got two separate parts, first one is the speech recognition and the other one is the language translation. So we got two different data sets for two parts of our system. So judging by the numbers here, you can see we got Kovo ST2 got 70 gigabytes of MP3 and also more than 700 megabyte of raw text data. So those already provide a massive volume of data set. And also these data set provide enough variety as in two part, as in the topics and also format. For topics, you can see that we got TED Talk transcription and also a lot of movie and TV subtitles. And for the format, we got different format of unstructured data, such as MP3 as for audio and the raw text in different language pairs. And also we provide our dataset have the velocity from our pre-processing framework quality, which will generate a result in a very short amount of time so that our translation and transcription won't lose any information. Here is the method of our entire system. So the first thing is the speech recognition, as we speak before. So the model we use is called FairSec S2T, which is a PyTorch sequence model developed by Facebook. So since it is a PyTorch framework, but we are actually deploying our system on Google Cloud. So it might face some difficulties on deployment, but this model is pretty easy for development. And this model also propose a lot of various state-of-art architecture, such as dual decoder transformer. So instead of only one decoder corresponding to one encoder, they got two different encoders and they have different way of communicating between those.
We implemented a transformer model trained with our dataset to do the translation in our system. The transformer model is a deep learning model that adopts the mechanism of self-attention, which was proposed by Google in 2017. Attention is a technique meant to mimic cognitive attention, making the network focus more on a small but essential part of data. The transformer model uses encoder and decoder architecture. Before the data is sent to the encoder, we should do the word embedding and positional encoding. Word embedding represents the word for text analysis in the form of the real value vectors, and the positional encoding will convert positional information of the word to the vector. Then the encoder will generate the encoding that contains information about correlation between words. And the decoder will take all encodings of and use their incorporated contextual information to generate an output sequence. After that, the output sequence will be passed into the softmax layer to make a prediction of words. We built our front-end web page using React and open source front-end JavaScript library for building user interfaces based on the UI components. Some advantage of React are that it's easy to learn and use and quickly creates a dynamic web application. After we built the web page, we deployed it on Google Cloud, which looks like the picture below. We use Blue to evaluate our system and algorithm for evaluating the quality of text from machine translation. The quality is considered the correspondence between prediction and the ground truth. And the higher value indicates a higher correlation between two sentences. Here is an example of the Blue evaluation. You can see the first sentence is similar to the reference, so it has the highest Blue score.
For our system overview, when the local audio upload to the cloud processor, the model will be process this information. System can be divided into the two parts, language understanding and the generation. The primary function of the language understanding is to split the complex sentence or paragraphs we can collect into the word, categorize them according to the same meaning, and then convert them into the information the model can understand. Next, the processed data information will be reproduced in the natural language through the second part of the language generation. When the content is determined, the model will be identify the field of the content and then use the professional vocabulary in this field, combined with grammar to construct a small sentence for the output. And we also have some challenges in our project, such as data noise, speech restriction, grammar correctly, sentence segmentation, text summarization, S2D development. And I will show a short demo for our project. Now, the web page we are seeing is our real-time translation system. The whole interface is very simple and there are almost no buttons. And I will show how to turn on the automatic translation function. Suppose we have a lesson to start now, and we can click on the new button in the upper left corner to create a new notebook. In the title input box, we can enter the name of this notebook. For example, Lecture 1. Then we can click the microphone icon on the top right to enable the real-time translation function. From now on, we can focus all our attention on listening to the lectures. Real-time translation will help us translate all English to Chinese and record it in the notebook we create. When we want to end the recording, we only need to click the microphone icon again to stop the recording function. Then click the Save button to save the notes of these lessons locally. Conversely, when we want to delete the note, we only need to click the Delete button and the note will be removed. On the left, we can see a directory of notebooks and summarized. The notebook directory is to store the saved note. The summarized directory is a summary of the content of each corresponding notebook. Here, we can create a new notebook to demonstrate the function of summarize. We can call it Lecture 2. It is Christmas. I got a card from my best friend, and I haven't seen in years. I am so happy. I haven't been happier than I am today since I separated from my friends 2 years ago. So I am very happy. Next, we can click the Summarized button to get a summary of the current text. Thanks a lot for watching our project demo.